Hope I did not say what I thought I said at the end of the video. So here, when I look at this question, right? So again, it's in simplified form, so we wouldn't want to like multiply things out. So we would look to simplify, by factoring, but x squared plus 3 does not factor nicely over the real numbers. It's just, it would have like plus and minus like radical 3i as its factors. Right, so then in terms of domain restrictions, anything in a denominator gets a chance to be a domain restriction. X minus 5 would equal 0, so x is 5, x is negative 2, x is 7. So then in terms of simplifying, so nothing in here actually simplifies, right? So our most simplified version of the function would just be what we already have, right? Nothing in the top and nothing in the bottom, not bottle, cancel out. Since nothing canceled out, that means there'd be no holes. It also means that every single one of those domain restrictions is going to end up being a vertical asymptote. So we have those three values. If we look at the degree of the top over the degree of the bottom, right, so the degree of my top would be x minus 1 to the first power. I have a squared there, so the degree of the top is going to be 1 plus 2, which is 3. The degree of the bottom, I have first power, first power, first power, which is also to the third power. So that means that the horizontal asymptote is going to be the ratio of lead coefficients of the top and bottom. All right, so if I look at the top, the lead coefficients is 4 because I have a 1x and a x squared. So if I multiplied everything out, we'd end up with a 4x cubed in the top. If I multiplied everything out of the bottom, I'd have 1x, 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 just an x cubed in the bottom. So 4 is going to be our horizontal asymptote. Our x-intercepts are going to occur wherever the numerator is equal to 0. So x minus 1 could be 0. So x equals 1 or 1, 0 is a x-intercept. X squared plus 3 equals 0, never. And this is also where understanding functions can help us out. Right? If you looked at x squared, right, we get a parabola. Normally, x squared would hit the x-axis at the origin. But if I shifted up 3, well, then what did hit the x-axis is now never hitting the x-axis, right? So there's going to be no real roots for that equation. And other key thing, which is going to be nice on the table of signs, right? So x squared plus 3 is always positive as well. All right, so then our y-intercept is going to occur when x is equal to 0. So if I just plop in a 0 for every x, right, we would get, let's see, 0 there, 0 there, 0, 0, 0. So we're going to get 4 times negative 1 times 3 times negative 5 times 2 times negative 7. So that numerator is going to give us negative 12. That denominator is going to give us positive 70. So what 2 goes in? So 6 over 35. This was, yeah. So negative 6 over 35 would be our y-intercept, 0, and then that value. Right, so that also gives us a value in our table of signs in a bit. All right, so speaking of table of signs, right, so first thing we want to do is see if we can analyze our table of signs a little bit smartly to not have to check every single last thing. So in here, the things that we know, right, so this 4 right here is obviously a positive value. That x squared plus 3 is also going to always be a positive value. Positives never affect our table of signs, only negatives. So we could really look at this in terms of a table of signs as x minus 1 over our denominator, x minus 5, x plus 2, x minus 7, right? That's going to be what we use in our table of signs for checking. All right, so then in here, we have a we have a vertical asymptote of negative 2, 5, and 7. We had an x-intercept at 1, 0, so maybe right there. Again, we had vertical asymptotes here, here, and here. And we had an x-intercept right here. Now, like I said, we already know something about our function. We know that when we plugged in 0, we got negative 6 over 35. So whenever x is 0, we're going to get a negative number. And that means that anywhere between -2 and 1, our function is going to be negative. So if I plug in anything less than -2 here, if I get rid of those values. And so if I plug in, say, -3, right, so my numerator is going to be negative. I get -3 minus 5 is negative. -3 plus 2 is negative. -3 minus 7 is negative. I have 4 negatives. I have an even number of negatives. We're going to end up having a positive value. If you're like, whoa, hold on a second. Negative divided by a negative is positive. Negative times negative is positive. Right, so all those negatives just become positive together. If I plug in something between 1 and 5, like say 2, right, so I'm just going to do it over here. So 2, 2, 2, and 2. I'm going to end up with a positive number in the top, 2 minus 1. 2 minus 5 is negative. 2 plus 2 is positive. 2 minus 7 is negative. Right, so again, I have an even number of negatives. That's going to be a positive value. If I plug in anything between 5 and 7, like 5.26 or 6, right, we're going to get 6, 6, 6, and 6. Right, so that's going to give us a positive number in the top. That's going to give us a 6 minus 5 is also a positive. 6 plus 2 is positive. 6 minus 7 is negative. Only one negative sign. So we're going to be negative on that interval. And then if we plug in something greater than 7, we're going to get a bunch of positive numbers, right? If I plug in 8 everywhere, 8, 8, 8, and 8. And so positive in the top, positive 8 minus 5, positive 8 plus 2, positive 8 minus 7. So everything's a positive there. So that means our function is only negative between -2 and 1, union 5 and 7. And then similarly, we're positive from negative infinity all the way up to -2. We're positive again between 1 and 5. And then finally, we're positive again from 7 to forever. All right, so that would be classifying these values, doing some rational functions, and all of the stuff that will be important both for quizzes and, I don't know, graphing in calculus.